5 times 5 is?
25.
Yeah. Hey folks, welcome out there. I got it out. I got out there, yes. Speaking of which, I'm Ernie Roberts, and we are so glad you tuned in this afternoon. You know what? It's kind of a dreary, wet day down here where we are, and maybe some of the places you're getting a lot of rain too. But I tell you what, let's brighten up our days and check it out, Mathline tonight. I want you to give us a call, all right? 844-686-2378. Gather around the TVs. This is raining outside. Hey, we'll just take care of things inside, all right? Just check us out, watch us, and call us. Again, 844-686-2378. Now you say, what do? We call, we talk, we solve problems, math problems, live on the air, and it doesn't cost you a cent. How about that? Great way to spend your afternoon? I think so, all right? So give us a call. Let's go. We've got operators waiting to take care of you. Again, that number 844-686-2378 if you don't have it in your speed dial already. Speaking of speed dial, let's take a look at problem of the day. This one says, at what very cold temperature are the Celsius and Fahrenheit scales equal to each other? Those are temperature scales, by the way, folks. Everybody knows that because it's at temperature, right? So again, at what very cold temperature are the Celsius and Fahrenheit scales equal to each other? Interesting problem there. So let's see how we're going to get an interesting answer on it. We're talking about conversions here, basically. And I'm going to remind you that when we go to Fahrenheit, we can put it like this. The Fahrenheit scale says if we take, and I think this one's probably the easier of the two to work with, 9/5 times the degrees Celsius, or 9/5, or if some of you like decimals, you can make that a decimal also. And then we're going to tack on, as a nice little afterthought, we're going to tack on 32. Now, if you'll think about that, that means if we had 30, if we had 0 degrees, if we had 30, we got to differ something else here, right? But if we had 0 degrees, we would be at freezing, all right? What we think of 32 degrees in the Fahrenheit. So if we had 0 degrees Celsius, be at 32 degrees freezing, but they're not the same, all right? So what we're trying to do, we're at the scales. In other words, when we set F and C, basically going to come out to be the same number. So we want to know, where does it happen? Where does it happen? You know, the best way to do that is, since they're both going to be equal to each other, let's remove one of the variables. All right, take C out of the picture or take F out of the picture and put C in its place or put F in its place, depending on which way we're going. So I'm going to leave the F where it is. We'll just say we're going to find Fahrenheit because, like I said, they're going to be what? They're one and the same. So it really doesn't matter which way we go on this. Now, I have 9/5. We're going to put that degree Fahrenheit. We'll put an F in there. A little algebra time, by the way, folks. And I have a 32 going on there. Looks good, all right? So again, we're looking for, where does this thing, it's going to be very cold, by the way. There is a hint right there. Certainly not like it is outside today, but it's going to be extremely cold. Let's see where this is going. We're going to first need to get our F's together, all right? And I think what would be wise on this one, let's just go ahead and subtract off, 9/5 off both sides. And we'll bring an F along for the ride. We're going to subtract both sides from there. And you say, well, Ernie, what is that going to do? Well, this is like having 1, remember. We sometimes forget there's a 1 in front of that F. So I am gathering that this is going to bring us to, how about it, a -4/5 F equaling, well, these are gone, right? Say goodbye to the 9/5 on the right, equal to 32. Now, some of you are looking at that going like, whoa, Ernie, that's going to be a negative number. It looks that way, doesn't it? Because we're going to be dealing with a negative fraction here, a positive here, and when we do a little division or a multiply by the reciprocal, exactly. So some of you are already wise to where this is going. So let's clean it up. Why not? Let's get the 5 out of there first. We'll pick up the 5. And by the way, some of you said, well, could you have gone ahead and done -5/4? Yes, we could. I'm going to take it one step at a time so we can just make sure we're going there, all right? And where is that going to take me? It's going to take me right up here a little bit. And the 5s are going to disappear. And over here we've got a 5/1, a 32/1. So we don't miss any fractions because there isn't one there now. That cleaned up our fraction out of 4/5. So we've got a -4F equaling, it looks like about, what, 160 over here, guys? I think that's 160. Looks like it to me. Y'all want to check? Let's check. Some of you out there doubting me. You shouldn't be. Let's see. We got 32 times 5 It is 160. That's good news. So at this point, where we're going to go is we're going to divide both sides by the -4. Back to our, there we go. And in doing that, good old division property of equality popping through, looks like we're going to end up with -40. And as I said, the big thing is, do we get a -40 when we put it back in here? You hope we do, don't we? So if we were to take 9/5 times -40, we'll check it out because we already know what the answer is on the left side. But if we were to take 9/5 times that -40, this is a check, by the way, okay, and add 32, the question is, will we get -40 back over here? That's a little freaky, isn't it? I'm hoping we will. Let's see what happens. If we divide, let's see, we divide 5 into 40, it goes 8 times, right? So we have a -72 plus 32. And do we get a -40? By the way, I don't know where that came from. It's not supposed to be there. It's just -40, and I believe we do. It checks through very nicely. -40 and -40. So there it checks. Real quick work back. And that, folks, is your problem of the day. If you had started out with it, there's another formula which takes us with basically Celsius equaling to 5/9 times in parentheses C minus 32 would work also. All right, you'd be able to work it that way too using that formula because both of those are conversions and we're looking for one precise point. One precise point, that is where both scales are going to equal -40. So either way, the formula will pop you right into -40. So there we have it. Good start to the show here. Hopefully you guys will give us some calls, make the show rock. We really, really do enjoy it when we hear the phones ringing and when we get you guys on the air. Yesterday, I know we had someone who called, one of our callers called and asked, when will we ever use this algebra? Well, keep in mind, folks, algebra is just the language of addition, subtraction, multiplying, and dividing. Anytime you do a recipe, anytime you do a formula, you're using some algebraic thinking. How do you double it? Do you take half of this? Do you run a formula to find the area? Do you want to know how much carpet you've got to put down on the floor? All of that it's mathematics. And it's a language, it's a formula that connects all these operations, adding, subtracting, multiplying, and dividing. So yes, in our thinking, our thought processes, how we solve a problem, it's algebraic, it's analytic. So don't think just because you say, well, I'm never going to see an X on the street. You may not, but you're going to probably think about, how do I get across the street? How do I weave in out of this traffic jam here? How do I do this? How do I do that? Legitimately, legally, and safely, all those good things. It's all a part of your daily life. So yeah, use a little bit of math around, okay? Guarantee you may not think about it because sometimes it just happens. You have to deal with it. But there are other times that you're going like, oh my goodness, I got to solve this problem. So problem right now, let's get some calls, all right? 844-686-2378. I noticed our caller yesterday that asked that question didn't want to go on the air, but I appreciate the question. Our fielder by our operator, Cooper. And you know what? That makes me feel like, yes, we do have people who are paying attention. And hopefully you heard that response today. But give us a call. We've got some great ways to go here in this show. I know some of you guys are not going to school tomorrow. There are a few places that are out for sickness and illness in the East Tennessee area. Don't know about Middle Tennessee. But remember, we got Middle Tennessee, Southeast Kentucky, Central Kentucky. We also have, goodness, Western Virginia, Western North Carolina. We want to hear from some folks today. All right, give us some calls here. It is Wednesday afternoon. We're about midweek, and we definitely want to hear from you and get some things going. So take care. It's your job, right? Make the show rock. We want it to do that. Now, let's go back to a little bit yesterday. We picked up and we got a caller. Marquez called and it was great to hear from him. And we didn't get quite through this distance problem. We got through one way, and I said there was possibly an easier way. But just to refresh your memory, and for those who weren't here yesterday, we had a distance formula which basically says take your x's, subtract them, take your y's, subtract them, and then square each of those individual quantities. Notice we wrote the little instructions here, but the formula, by the way, whenever we say when do we ever use algebra, anytime we have a formula, we got to know what to do with it. What order do we go in? How do we work through these things, etc. So substitution, subtract, square. Now we have to wait to add, all right? Then we come back, and after we've added, we do the square root, and we came up with the number 15 yesterday. Now, what I would like to do is I'd like to graph these 2 points, and if you have graph paper, I think it's just as easy, if not easier, to find the distance on the graph as it would be to go through the distance formula. However, if you don't have a graph page and you're given a distance formula, grab it and use it. Both ways are legit, both ways work. Now, let's see how this is going to go. I've got the points. Let me pull them back over here just a second. I have -4 and 6. So we're going to go, whoa. We're going to go to the left 4, and we're going to go up 6. And on top of that, we have, well, not on top of that, it's going to be actually a little bit to the right. We're going to go with 5 across to the right and down 6. Make sure I got right enough blocks there, okay? So 1, 2, 3, 4, 5, and then we go down 1, 2, 3, 4, 5, 6. So here is our situation. Now the whole idea, folks, when we were looking for a distance, is to find how far is it from point to point. How many units do we have going from point to point? Now, look at what's going on there. We're on a diagonal, so to speak, aren't we? Now, I'm not looking for slope, but the ingredients of slope are going to help me out a little bit here, all right? We're going to come along here. We're going to create a right triangle. Get a right triangle going here. So we're going to make a little, I'm going to do broken lines here, okay? Because we're not really trying to make this part of the picture. We're just showing what we're going to do. We're going to show how far down do we go to get to there. How far down we count. Kind of sounds like a rise, doesn't it? Or in this case, a drop. But you get the idea. And then we're going to take a, you got it, a run right across there. So slope has a little bit to do with distance. At least the characteristics that make the slope are also going to help us find the distance. We have to count how many blocks we've used up here. My goodness, how many were there? We should have counted along the way, shouldn't we? Looks like we've got 1, 2, 3, 4, 5, 6 coming down to there. 1, 2, 3, 4, 5, 6 more. So that's going to give us 12 over here. Did that sound familiar? I think we had 12 units. So what about, Ernie, do we want to put a -12 on there? Really don't. We're talking about how long a distance is it, but understand it is going down, so it is a -12 if you're thinking of a rise-run moment, okay? Going across, let's see what we got. 1, 2, 3, 4, 5, 6, 7, 8, and there's 9. So our run looks like it's going to be 9. And I circle these because they're important numbers. If you remember, on the distance formula, we ended up with that -9, which we squared, and we ended up with a 12 also, which we squared. And look what's happening here. We got a good old right triangle, and what happens there? You got it. How about it? You go what I'm going for. Everybody knows what I'm going for, right? A squared plus B squared equals C squared. Now, as we look at what we got there, that C is basically the distance, isn't it? So we'll just call it D, and we'll go from there. So let's play it out. We got 12 squared. We have a 9 squared. And I'm going to go ahead and call that D squared, all right, because that's our distance, what we're looking for. It is the hypotenuse of that right triangle. And if you're on graph paper, I think it's a lot easier to count blocks than it is to go through the whole distance formula and take a chance on making a miscalculation of some sort, right? So let's go with it, 144. And if you know your perfect squares, this really rocks out pretty quick. And we've got, by the way, that's what 12 times 12 is. Good old multiplication table. Perfect squares, right? 12 squared, 144. I've got 9 squared, which gives me a nice 81 there. And, ooh, starting to look kind of like what we had earlier, isn't it? Now, let's add those numbers together, because remember, that's what we do now. And it really does. It sounds just like what we do with the distance formula. Absolutely. Because we basically counted blocks. That was like subtracting. We decided we'd square the results. That was what it said to do. And you know what? We have 225 when we add those together. And let's go square root hunting here. And we have 15 equaling the distance. And my friends, it's the same value we had over there. Now, some of you may ask, what happens if it didn't come out even? Well, usually the instructions are take it to the nearest hundredth or nearest tenth. Sometimes they ask for a simplified radical form. This time it just simplified out very nicely. We could actually say that's 15 units from point A, so to speak, to point B. There you have it. Little distance formula. Also solving it with just using a graph and a grid. Works great. And speaking of which, I understand I have a call waiting for me. Welcome to Mathline this afternoon. Who am I talking with?
This is Anthony from West High School again.
Anthony, good to hear from you. You get a day off tomorrow, don't you?
Yes.
Hey, congratulations, congratulations. But thank you for calling us this afternoon. What can I do for you this afternoon?
Well, I got another equation
All right.
for you to solve.
Excellent.
And it is x equals 16.
Okay.
And 18y plus 48x equals 32.
Oh, goodness. 18y plus what? 42x, you say?
48x.
48. Okay, we want to make sure we get those right. X equals to what?
32.
32. Let me rewrite that. It's kind of look a little sloppy here. We got x equals 16. That's a given, right?
Yes, sir.
And 18y plus you said 48x
Yes.
equals to 32. And the biggest thing here is we just got, looks like we've got a lot of big numbers, don't we, looking at us here.
Yes.
So the deal is we know x, so we're going to use x, which is 16, and we're going to bring it right over here like a little missile hunting it down right over there. Here's the x. And we're going to substitute. We're going to substitute that right in there. So we got 18y plus 48. I'm going to put a 16 in there. And that's supposed to equal 32. So far, so good? You see where I am? All right, very good. Now, from here, what I'm going to do is, I guess I need to multiply 48 times 16, and I'm not that good. I have to use a calculator on this one. So let's see what we've got here. 48 times 16 looks like, 768. Does that sound good to you?
Yes.
All right, so we got 768 equaling to 32. I want to get y by itself. I want to get y by itself. So here we go. Here we go. Subtract 768 from both sides. And that's going to be a pretty interesting value. Again, we'll go to the calculator for that. And you got 18y hanging on by itself, correct?
Yes.
So let's pick it up here. Let's see what 32 minus 768 is going to do for us. It gives us something that looks good. I'm seeing a negative 736. Let's check out. We're going to need to divide, right, by 18.
Yes.
I hold my breath and hope this will come out with something that's nice and even. And at least with maybe if it has a half or something like that, it won't be so bad. Let's see what we've got here. Divided by 18. Ooh, not very pretty, is it? I'm getting a negative 40. And that actually, if we change that to a fraction, is going to be 8/9. Okay? And I guess that is really fine because you're not having to plug it back in and make sure that we'll find what x is there. But did we get everything down right? Did we get all our signs in there correct?
Yes.
18y plus 48, x equaling 32. And we did put a 16 in there as a substitution. And we didn't miscalculate that one because the calculator says 48 times 16. I'm still looking at it. And that's where it comes out. Does that work for you?
Yes.
It doesn't always, they don't always come out pretty, but, and by the way, how did I know that? Because it's 0.88888888, which means it's a repeating decimal. Basically, what they did on the 9, they rounded up. So that comes out to 8/9 for you as a fraction. Okay?
Okay.
All right. Hey, thanks for our question today. And again, sometimes those answers, folks, don't always come out pretty. All right, just like life is occasionally, right? So, Anthony, thanks for giving us a call on that. And you know, those are some of the. It's easy to do, my friends. He did it. And come on, give us a call 844-686-2378. We do have, and we have been running a problem of the week. Let's take a look at that one today, all right? See what we've got going for us in this week's time. Guys, let's repeat what it is here. There it is. Our problem of the week says we're on a floor plan of a room drawn to the scale of 1/8 inch equaling 1 foot. What are the dimensions of a room whose plan measures, says 1 5/8 inches by 2 3/4 inches. Now, remember what I said yesterday? Those are the plan is small, drawn small, okay? then we have to envision how much bigger, this is a rectangular room it sounds like, and see how it's going to look. So let's do something about these inches here. Another little push on the play here. Let's go ahead and make some improper fractions here. This will help us out. We have, and notice this dimension over here, 2 3/4 is a lot larger than 1 5/8. So I'm going to change 1 5/8 to, well, what are we going to change it to? How about 13/8? Make it improper. And I'm going to take the little x out of there because we're really not going to multiply it. We're not worrying about the area of that room. We're just talking dimensions here. So by 2 3/4, that's going to give us 11/4 inches. Now, what you need to do is realize that this is the scale that these are both working on. So you want to come up with some way to transport from this 1/8 inches to 13 inches over 8. It's kind of we're playing a ratio game here. We gave you a hint here because once we get there, we're going to be able to say, looks like how many feet we're going to have, okay, with using that 8 to go through there. And I think if we do that, it'll give us an idea there what's happening there. So also down here, it's kind of like how do we get from 1/8 inch scale to that 11 inches over 4. That's one way of looking at it. Other ways to look at it also. But in my mind, I think I'm seeing an answer already appearing here, if you will let it happen. What did you multiply? Well, what's this representing when we get to this point? If 1/8 of an inch equals 1 foot, what should 13/8 give you? That becomes a real easy concept. And if you need a little help on that, maybe you might want to change those too. We'll reveal the final answer tomorrow on the show, all right? As well as some of you all have been looking at Facebook. I wanted to also give a quick shout out to Mark and Margie on top of that one today. They did have -40 already correct, ready to go. And good job with that involved here. Let's take a look at one more thing here while we're waiting for maybe a call or two. We're going to look at a right triangle here with side length of 8 and hypotenuse of 17. Find the area of the triangle. Now, we just created a right triangle. A minute ago by using Pythagorean Theorem. It looks like we've got another problem here. Let's see if we can create this little right triangle. See if I can do it without messing it up too badly. There we go. And then we got a long leg, much longer leg. You know, I knew that because the hypotenuse is rather long. So let's continue right up through there. And here's the information, by the way. There's your right angle working for you. We have a length of 8, and we have a hypotenuse of 17. The question is asking, can we find the area? Now, for those of you who've forgotten area of a triangle, again, remember I mentioned formulas earlier for our viewer who said, when do we ever use this algebra? Here's one place where we do it. We have a formula that says 1/2 base times height. I want to know how much area is in there. Maybe I wanted to carpet the space. Maybe I'm wanting to dig it up. It's a flower garden. I don't know. But one thing I do need to know is, what is this missing dimension right there? Because that's my base. There's the height. And we're going to call upon our friend the Pythagorean Theorem to get us out of this thing. So if y'all drop my lower third just a second here, we're going to say 8 squared plus x squared. That's going to give us that 17 squared business right there. And again, remember I keep talking about these perfect squares. It is nice to know them so you don't have to go punch on the calculator. 8 times 8, I think everybody has that one taken care of. I have an x squared because I don't know what it is yet. We're looking for that. We want to find that out. Now, what is 17 squared? 17 squared is going to give us 17 times 17. So we're going to punch, punch, punch. So we're going to punch, punch in the brain. Got it. 289. 289. You say, how did you know that, Ernie? Because you learned a few of those perfect squares along the way when you use them over and over again, right? So kick this thing over here. We got 64 plus our x squared equaling 289. Let's lose the 64. Why not? And I'll tell you what's going on here. Is this not an interesting situation? We got 225. Everybody knows that one because you just saw the show a minute ago, right? What's the square root of 225? We're back at x equaling 15. You say, oh, problem's done. Not quite. we got to come back and use our formula. Here we go. 1/2, what's the base? It's 15, times the height of 8. Make that really look like an 8. There we go. And you know what? I'm catching 60. And since these, well, it didn't give us whether it's inches, feet, or whatever, but we'll call them square units of whatever it might be, feet, miles, whatever. I doubt it's miles. But anyway, there you go. That would be your deal on that. Easy use of the formula, square units for the area, Pythagorean Theorem. See how it all fits together? And it wasn't that hard, was it? Hey, folks, thanks for tuning in. Anthony, thank you for calling in, and hope you enjoy your day off tomorrow. Those of you who are suffering with flu and all those things, get well soon. We really do. We want to hear back from you. Also, we'll be back live tomorrow, and we look forward to hearing from you guys, tuning in with us, and also give us a call. We will see you again next time. Thank you again.